For decades, we had this really neat, tidy story about how the universe began, a slow, orderly process of creation. But what if that story is just wrong? Today, we're going to look at how the James Webb Space Telescope isn't just taking incredible pictures, it's completely rewriting our entire cosmic origin story. And this quote, man, it just perfectly sets the stage for what we're about to get into. Elegance is not evidence. It's this gut check reminder that just because we want a simple, clean narrative about the cosmos, well, that doesn't mean the universe has to play along. And it turns out it really, really isn't. So who's the culprit behind this cosmic shakeup? Well, of course, it's the James Webb Space Telescope. But you gotta think of it as more than just a telescope. It's a temporal probe, a time machine. By looking deeper into space than we ever have before, it's sending back dispatches from an era we could only guess at with simulations. And these dispatches, they're revealing a young universe that's dynamic, uneven, and surprisingly, decisive. So to really get why these new dispatches are such a big deal, we gotta rewind a bit and look at the story they're replacing. Let's dive into the old cosmic narrative, the one we all learned. For the longest time, the standard model painted this picture of a really patient universe. The idea was that after the Big Bang, everything assembled slowly, piece by piece, from the bottom up. Little things clumped together to make bigger things over billions and billions of years. It was hierarchical, it was predictable, and it was uniform, a reassuringly calm and orderly story. And then JWST switched on. And this is where our story takes a very sharp turn. See, it's not just an observer in the story, it's an active character, and it's challenging everything we thought we knew. Okay, so let's quickly unpack this temporal probe idea, because it's pretty mind-bending, but also kind of simple. Light takes time to travel, right? So when you look at something really, really far away in space, you're also looking back in time. When JWST sees a galaxy billions of light years away, it's seeing that galaxy as it was billions of years ago. It's giving us a direct look at cosmic dawn, the universe's infancy. For the first time, we have photographs, not just theories. All right, so what has this time machine actually seen? What's in these dispatches? Well, it sent back 4 major surprises, 4 bombshells, really, that are forcing a complete rethink of the early universe. Let's break them down. Dispatch number 1. Right out of the gate, instead of seeing these faint, tiny little beginnings, JWST found massive, super bright structures at a redshift over 13. Now that just means we're looking way, way back in time, to when the universe was only a few 100 million years old. To put that in perspective, that's like finding a fully built skyscraper just a couple of years after someone invented the first brick. It's way too big, way too small. So the crucial point here is that this discovery strikes right at the heart of that whole patient builder story. The universe wasn't slowly putting things together like Lego blocks. It was capable of incredibly rapid, efficient organization. Gravity wasn't messing around. It was acting decisively, right from the very start. Okay, let's move on to our second dispatch. This one is all about a process called reionization. It's basically when the universe went from being this murky, neutral fog to the transparent state we see today. The old story was that this fog kind of lifted everywhere at once, like a light switch, flipping on for the whole universe. But nope, JWST shows that's not what happened at all. It was patchy. There were these stubborn pockets of cold, neutral gas that survived for much longer in the densest regions. And this reveals a totally new principle. There wasn't one single clock for the whole cosmos. The universe didn't evolve in lockstep. What was happening locally, specifically, how dense the matter was in one spot versus another, was way more important than some global timeline. Evolution was a local affair, not a uniform global event. Now for dispatch number 3, and this one tackles these mysterious little red dots that JWST keeps finding. At first, everyone thought, okay, these must be the very first galaxies, glowing from their first baby stars. But it turns out that's not the whole story. Not by a long shot. Many of these objects are actually powered by something else, entirely. Intense gravitational energy from matter spiraling into supermassive black holes at their centers. These are accreting cores. Okay, pause and think about what this really means. If the brightest things out there are powered by gravity literally pulling stuff into these super dense cores, and not by stars, well then the whole idea of building galaxies from the bottom up, star by star, gets completely turned on its head. It suggests a more direct, maybe even a top-down process of organization was really running the show. And the last dispatch? Just as mind-blowing. JWST has found sleeping beauty galaxies. These are galaxies that just stopped forming stars. They quenched way before the universe was even a billion years old. According to all the old models, this shouldn't have happened for many more billions of years. What this implies is that the universe had a built-in off switch right from the very beginning. It wasn't just good at building things fast, it was also good at stopping that growth just as quickly. It suggests there's this internal self-regulating mechanism where once you hit a certain density, the system just says, okay, that's enough, and shuts down star formation. So, okay, we've got these 4 dispatches, and the old story is, well, it's in shambles. So how are scientists even beginning to make sense of this new, way more complex and honestly, way more interesting universe? And this right here lays out the battle perfectly. On one side, you have the old story. Smooth, slow, everything happening in sync. And on the other, the new reality from JWST. Messy, fast, and totally driven by what's happening locally. The narrative has fundamentally split from the standard model we used to have. So this leaves scientists with basically 2 paths forward. Path 1, try to patch up the standard model. Our current best theory, lambda CDM. This means adding all sorts of special conditions and fine-tuning like bursty star formation or super-efficient black holes to make the old theory fit the new data. Or path 2, consider a whole new framework, like the S-matter framework that's built on different principles from the get-go. And that's where something like the S-matter framework comes in. The idea here is that you don't need all those special patches. It's built from the ground up on principles that, well, they just seem to fit what JWST is seeing naturally. That local density is king, that gravitational energy was the mean event early on, and that evolution was never uniform. These few core ideas seem to explain all 4 of those surprising dispatches we just walked through. And this brings us to the real bottom line, the crucial point in this whole scientific revolution. Where do we actually go from here? Now, it is so important to be clear about this. JWST hasn't proven the S-matter framework or any other single new theory. It hasn't crowned a winner. What it has done, though, is systematically pull the rug out from under the old story's core assumptions of smoothness, slowness, and uniformity. The burden of explanation has totally shifted. It's no longer on new ideas to prove they're needed anymore. Now it's on the old model to justify itself, to prove it can still work without being duct-taped together. The path forward is going to rely on the next generation of instruments, like ALMA and the Square Kilometer Array, to really test the specific falsifiable predictions that these new ideas are making. This is science in action, and it's awesome. And that leaves us with one last question to chew on. Has the James Webb Space Telescope revealed a universe that is just fundamentally more complex than we ever dreamed? Or has it simply shown us that our preference for a neat, elegant story was, in the end, just a little too simple for the beautiful, messy, incredible reality of our own cosmic dawn?